The flashlight battery makes light energy. If you write that on your Cambridge IGCSE physics exam, you've literally just lost the mark before the examiner even finishes reading your sentence. Zero fluff today. Let's dive straight into the crucial difference between a typical response that bleeds points and a top-band Cambridge physics answer. Today we're exposing the tiny phrasing mistakes that are secretly tanking your grades and replacing them with an unstoppable, mark scheme-approved strategy. This tiny mistake of saying energy is made instead of transferred costs marks instantly. You know, students do this all the time. They think ordinary revision, like just memorizing that batteries give us light, is enough. But ordinary revision fails because it completely ignores the strict vocabulary the examiners are hunting for. Compare that to a top-tier answer. Electrical current transfers energy from the chemical store to the bulb's internal store. Notice the precision there? Energy isn't created, it moves. And today, we're going to fix your phrasing so you automatically write exactly what the examiner wants to see.
We're pulling our framework directly from the Cambridge IGCSE Physics coursebook to ensure you're using the exact examiner-approved terminology. Think of this as our map. It breaks down energy stores and transfers, moving us away from vague everyday language into precise scientific reasoning. Because in the exam, you need a solid framework. Identify the concept, back it up with evidence from the physical situation, apply your scientific reasoning, and then deliver it in exam-safe wording.
Section 1. The 4 transfer pathways.
To build a high-scoring answer, you first need to identify exactly how energy is moving between stores, using what Cambridge recognizes as 4 specific pathways. Think of these as invisible bridges. Let's dive into the first pathway, mechanical working. This is all about transferring energy from one object to another by means of a force. If you lift something or start it moving, like pulling back the elastic on a catapult, you're providing a force. That force transfers energy to a gravitational potential store if you're lifting it, or a kinetic energy store if you're moving it. The physical push or pull is the key here. Next up is thermal working, or heating. What's really interesting about this concept is its absolute inevitability. We all know thermal energy spreads out from hot objects. But the crucial point is that no matter how excellent your insulation is, energy is constantly being transferred from a hot object to its cooler surroundings. It's a relentless pathway. Basically, if there's a temperature difference, thermal working is happening. The third pathway is radiation. Now, when we say radiation in this context, we mean energy that's transferred using electromagnetic waves. Light reaches us from the sun through this exact pathway. But remember, this isn't just visible light. It also critically includes infrared and ultraviolet electromagnetic radiation. So when a light bulb illuminates a room, the energy from its internal store is transferred to the surroundings via light radiation.
Finally, we have electrical working. This is transferring energy from place to place using electric currents. Now, in a moment, I'll show you the exact examiner clue regarding time that changes your answer completely. But first, you need to understand this final pathway to make that clue completely obvious. Whether it's power stations setting electricity across the country or just a simple battery and a flashlight, electrical currents are the ultimate convenience pathway for moving energy. It essentially transfers energy from the chemical store of the battery to the internal energy store of the bulb.
And this brilliantly illustrates our most important key phrase. Whenever you see the phrase doing work on an exam, you've got to instantly connect it to a force causing an energy transfer. Doing work is mechanical working. It's not about sitting at your desk studying. In physics, if a force isn't moving something, work isn't being done. Lock this definition into your brain.
Section 2. Spot the physical clue.
Let's apply this framework to an examiner-style data table where we have to map what we see in the physical world to what is actually happening invisibly with energy. Examiners love giving you a scenario and asking you to deduce the hidden physics. I want you to treat this as an interactive checkpoint. Pause the explainer right here, look at this recreation of Table 6.2 from our source. Ask yourself, if an object changes speed, which specific energy store must be changing? What about if the material changes shape? Okay, let's do an examiner-style correction right now. If it changes speed, the kinetic energy store is changing. If the distance between objects changes, say they're moving farther apart against gravity, the gravitational potential energy, or GPE store, is changing. Linking the physical clue to the correct energy store is exactly how you build your evidence.
Section 3. The nuance of time.
Let's see how this builds into the subtle examiner clue I promised you. There's a vocabulary trap that catches so many students out, confusing an event with a process. This is where top-tier students completely separate themselves from the rest of the pack.
Examiners look for absolute precision in your language, so you really must understand that energy is only transferred or changed during these two specific temporal windows. An event is something that happens or takes place, often at a very specific time and place. A process, on the other hand, is a series of actions or steps, often taking place over a long period of time. Energy only flows when something is actually happening.
Let's ground this in reality. Striking a match is an event. Falling over is an event. They're instantaneous. But burning, climbing a mountain, those are processes. Striking the match is the instant event, but the resulting burning is the long-term process, and energy shifts dynamically through both. Sometimes it's kind of difficult to tell them apart, but the crucial takeaway here is that energy transfers only occur during the event or the process itself.
Section 4. Building top-band answers.
Okay, the stakes are getting higher. Let's look at how we combine everything into a flawless response. It's time to build a top-band answer. Here's our classic flawed answer. When you lift a box, you use up your energy to pull it up. Spot the error? This is a massive red flag for examiners because the phrase using up implies that energy simply disappears into nothingness. It completely ignores the mechanical working pathway we just defined, and it totally violates the core principle that energy is transferred, not destroyed.
Now look at the completely transformed top band answer. By providing the force that lifts the box, you are doing work. Energy is transferred from your chemical store to the box's gravitational potential energy store. Notice how this brilliantly illustrates the exact definitions from our source material. It identifies the starting chemical store, explicitly names the doing work transfer pathway via a force, and identifies the final GPE store. This is how you guarantee maximum marks. It's precise, it uses the right vocabulary, and it paints a complete picture of the physics at play.
But here is the ultimate diagnostic cliffhanger. Understanding energy stores and transfers is really only half the battle. If energy is only transferred during events and processes, which command words on your exam will dictate whether you just state the event or fully explain the process. Misreading these command words is the hidden cause of lost marks for even the smartest students. In our next explainer, we're going to decode the exact Cambridge command words that decide your mark band so you never overwrite or underwrite an answer again. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Join us in the next explainer to decode those final command words.